The Triassic period, spanning from approximately 250 to 201 million years ago, marks the beginning of the Mesozoic era, a time often referred to as the Age of Reptiles. This period followed the Permian-Triassic extinction event, the most severe mass extinction in Earth's history, which wiped out nearly 90% of all species. The aftermath of this extinction created a world of ecological recovery, where new life forms began to emerge and ecosystems underwent significant transformations. The Triassic world was characterized by a hot and humid climate, with vast deserts dominating much of the supercontinent Pangaea. This massive landmass allowed species to spread and evolve across connected habitats, fostering the rise of new groups of animals. Vegetation during this time included conifers, cycads, and ferns, forming the basis of ecosystems that supported the first dinosaurs. Despite the harsh conditions, the Triassic period set the stage for the incredible diversification of life that followed. 1. Discovery of the Triassic period and dinosaur species. Dinosaurs made their first evolutionary appearance during the late Triassic period, around 230 million years ago. Evolving from small archosaur ancestors, these early dinosaurs showcased remarkable adaptations that allowed them to thrive in a rapidly changing world. Creatures like Eoraptor, often considered one of the earliest dinosaurs, were small, bipedal, and agile, making them effective hunters and foragers. Another early dinosaur, Herrerasaurus, was larger and displayed advanced predatory traits, including strong hind limbs and sharp teeth. These early dinosaurs occupied diverse ecological niches, ranging from predators to herbivores. Their upright posture and efficient locomotion gave them an advantage over sprawling reptiles, allowing them to move quickly and conserve energy. This adaptability enabled dinosaurs to begin their rise to dominance, gradually outcompeting other reptilian groups. The Triassic period represents the humble beginnings of the dinosaur dynasty. From small, opportunistic creatures, dinosaurs began a journey that would lead them to become the rulers of the Mesozoic world, shaping ecosystems and leaving a legacy that endures to this day. 2. Changing environments and their impact on species development. Climatic changes and plant evolution. The Triassic period was a time of significant climatic and environmental shifts, which played a critical role in shaping the evolution of life on Earth. The supercontinent Pangaea, stretching across much of the globe, created vast interior deserts characterized by arid conditions and extreme temperature fluctuations. These dry environments were periodically interrupted by monsoonal rains in coastal and equatorial regions, creating alternating periods of wet and dry climates. These shifts fostered the development of diverse ecosystems, from arid deserts to lush floodplains. Plants were among the first to adapt to these changing environments, with groups such as ferns, cycads, and gymnosperms, cone-bearing plants, becoming dominant. Gymnosperms, in particular, thrived in the hot, dry conditions of the Triassic due to their efficient water-conserving adaptations, such as needle-like leaves and protective cones. These plants formed the foundation of terrestrial ecosystems, providing food and shelter for herbivorous animals, including the earliest dinosaurs. The evolution of these plants set the stage for the ecological complexity that would characterize the later Jurassic and Cretaceous periods. Survival competition and evolutionary drivers. The harsh ecological conditions of the Triassic acted as evolutionary drivers, forcing animals to develop survival strategies to adapt to their surroundings. Dinosaurs and their contemporaries faced intense competition for resources, which shaped their evolutionary paths. Early dinosaurs such as Eoraptor and Coelophysis benefited from their bipedal stance and efficient locomotion, which gave them an edge over sprawling reptiles by enabling faster movement and better energy conservation. Predatory dinosaurs honed their hunting skills with traits such as sharp claws, serrated teeth, and keen senses. Herbivorous species evolved defensive adaptations such as robust body structures and herd behaviors to protect against predators. Beyond physical adaptations, behavioral strategies like burrowing and seasonal migration helped species survive the Triassic's unpredictable conditions. This dynamic interplay of climatic shifts, plant evolution, and survival competition catalyzed the diversification of life during the Triassic period. It was a crucible of evolution, where adaptability determined survival, setting the foundation for the dominance of dinosaurs and the flourishing of new ecosystems in the Mesozoic era. 3. Dinosaur species, domination and evolution during the Triassic period. Early dinosaur species, ecological characteristics and classification. The late Triassic period witnessed the emergence of some of the earliest dinosaur species, marking the beginning of their evolutionary journey. Among the first were prosauropods, early herbivores that would later give rise to the massive sauropods of the Jurassic period. These dinosaurs, such as Plateosaurus, were characterized by long necks, robust bodies, and relatively large sizes compared to their contemporaries. Their physical traits allowed them to access vegetation in diverse habitats, from low shrubs to taller trees, giving them a competitive edge in feeding. Triassic theropods, including species like Herosaurus and Coelophysis, were agile carnivores that displayed advanced predatory adaptations. They were bipedal, with powerful hind limbs for swift movement and sharp, serrated teeth for slicing through prey. Herosaurus, for example, stood about 3 meters long and was among the apex predators of its time. These early theropods laid the foundation for the diversification of predatory dinosaurs in later periods, including iconic species like Tyrannosaurus rex. Dinosaurs during the Triassic were relatively small compared to their Jurassic and Cretaceous descendants, but their upright stance and efficient locomotion set them apart from other reptilian groups. These traits enabled them to exploit new ecological niches, gradually establishing their dominance in terrestrial ecosystems. Growth patterns and ecological adaptations. Dinosaur fossils from the Triassic reveal remarkable growth patterns and ecological adaptations that help them thrive in a variety of environments. Analysis of bone structures shows that many early dinosaurs exhibited rapid growth rates, a trait that allowed them to reach maturity quickly and compete effectively for resources. This growth strategy may have been a response to the intense survival pressures of the time. Ecologically, dinosaurs adapted to a wide range of environments, from dense forests with coniferous trees to more open floodplains and arid landscapes. Their ability to inhabit diverse ecosystems reflects their evolutionary flexibility. Herbivorous dinosaurs like Plateosaurus were capable of digesting tough plant material, while carnivorous theropods evolved sharp claws and keen senses for hunting. By the end of the Triassic, dinosaurs had established themselves as key players in ecosystems, setting the stage for their eventual dominance in the Jurassic and Cretaceous periods. 4. Triassic ecosystems and dinosaur survival strategies. The development of other animal groups. The Triassic period was a time of ecological recovery and innovation, marked by the emergence of not only dinosaurs but also a diverse array of other animal groups. Fish and marine reptiles thrived in the oceans, contributing to dynamic aquatic ecosystems. Early marine reptiles, such as ichthyosaurs and nothosaurs, adapted to life in the water with streamlined bodies and efficient swimming abilities, becoming top predators in marine environments. Small mammals, evolving from synapsid ancestors, also made their first appearance during the Triassic. Though overshadowed by the larger archosaurs and early dinosaurs, these mammals demonstrated remarkable adaptability, occupying ecological niches as insectivores and seed gatherers. Their nocturnal lifestyles helped them avoid larger predators, ensuring their survival during a period dominated by reptiles. Amphibians and early crocodilian relatives also contributed to the diversity of the Triassic ecosystems, creating a complex web of interactions that laid the groundwork for future evolutionary advancements. Survival and evolutionary strategies. Dinosaurs emerged as dominant players in this complex ecosystem by developing effective survival strategies that gave them an edge over competing species. Migration was one such strategy, as dinosaurs were able to traverse vast distances across the connected supercontinent Pangaea in search of food and favorable climates. This mobility allowed them to exploit seasonal resources and adapt to different environmental conditions. Pack hunting and social behavior also played a crucial role for certain species, particularly theropods. Evidence from fossilized trackways suggests that some dinosaurs, like Coelophysis, may have moved and hunted in groups, improving their chances of capturing prey and defending themselves against larger predators. Rapid reproduction and growth rates were another key to their success. Early dinosaurs reached maturity quickly, reducing their vulnerability to predators and increasing their population resilience. Fossil evidence of nesting sites, such as those of Mosaurus, suggests that some dinosaurs exhibited reproductive behaviors, including group nesting and parental care, which further enhanced their survival rates. These survival strategies, combined with their physical adaptations and ecological versatility, enabled dinosaurs to dominate the terrestrial ecosystems of the Triassic period. By the end of this era, dinosaurs had outcompete many rival groups, setting the stage for their reign as the undisputed rulers of the Mesozoic era. 5. Extinction events and their impact on dinosaurs. Carnian pluvial event, climatic shifts and ecological consequences. The Carnian pluvial event, occurring approximately 234 to 232 million years ago during the late Triassic, was a period of intense climatic upheaval that profoundly affected ecosystems. Characterized by a sudden increase in rainfall, this event transformed arid regions into wetter environments, causing significant changes in vegetation and altering the distribution of species. Fossil evidence suggests that this period saw a decline in many species of early reptiles and amphibians, creating ecological gaps that dinosaurs were poised to exploit. The increased rainfall, likely triggered by volcanic activity and the release of greenhouse gases, led to widespread flooding and changes in habitat availability. Forests expanded as gymnosperms and ferns thrived in the wetter conditions, providing new opportunities for herbivorous dinosaurs. This period also likely contributed to the diversification of early dinosaurs, as they adapted to take advantage of these newly formed ecosystems. Carnivorous theropods such as Coelophysis and herbivorous prosauropods like Plateosaurus began to spread and establish themselves as dominant species during this time. The Triassic-Jurassic extinction, causes and consequences. The Triassic-Jurassic extinction event, occurring around 201 million years ago, marked the end of the Triassic period and paved the way for the dominance of dinosaurs in the Jurassic. This mass extinction was triggered by massive volcanic eruptions associated with the Central Atlantic Magmatic Province, CAMP. These eruptions released vast amounts of carbon dioxide and sulfur dioxide into the atmosphere, causing rapid global warming, ocean acidification, and widespread anoxia in marine environments. This extinction wiped out approximately 50% of species, including many of the large archosaur competitors of early dinosaurs, as well as marine reptiles and large amphibians. By eliminating these rivals, the extinction event created ecological gaps that allowed dinosaurs to diversify and expand into new niches during the Jurassic period. Herbivorous dinosaurs took advantage of abundant plant life, while carnivorous theropods rose to dominate terrestrial food chains. The Carnian pluvial event and the Triassic-Jurassic extinction were pivotal moments in Earth's history, shaping the evolutionary trajectory of dinosaurs. These events demonstrated the resilience of dinosaurs and their ability to adapt to rapidly changing environments, setting the stage for their unparalleled success in the Jurassic and Cretaceous periods. 6. Dinosaurs and the Golden Age of the Jurassic period. The Jurassic period, the pinnacle of dinosaur evolution. The Jurassic period, spanning approximately 201 to 145 million years ago, marked the Golden Age of dinosaurs, as they rose to dominate the Earth following the ecological shifts caused by the Triassic-Jurassic extinction. This period was characterized by warm climates, abundant vegetation, and the breakup of the supercontinent Pangaea, which created new landmasses and ecosystems. These conditions allowed dinosaurs to diversify and thrive, leading to the evolution of some of the most iconic species in Earth's history. Large herbivorous dinosaurs such as Brachiosaurus and Diplodocus became dominant in terrestrial ecosystems. Sauropods, with their massive sizes and long necks, were uniquely adapted to feeding on high vegetation, allowing them to exploit resources that were out of reach for other herbivores. Meanwhile, carnivorous dinosaurs like Allosaurus and Ceratosaurus occupied the top of the food chain, using their powerful jaws and sharp teeth to hunt prey or scavenge carrion. These apex predators played a critical role in maintaining ecological balance. The Jurassic also saw the diversification of smaller, feathered theropods like Archaeopteryx, which represented a significant evolutionary link between dinosaurs and birds. This period set the stage for the later dominance of birds as the only surviving lineage of theropod dinosaurs. Evolution of dinosaur species. Fossil evidence from the Jurassic reveals significant changes in dinosaur morphology and behavior. Sauropods, for instance, developed lightweight skeletal structures, including hollow bones, which supported their enormous sizes while reducing their overall body weight. These adaptations allowed them to grow to lengths exceeding 30 meters. Carnivorous theropods evolved strong, flexible necks and reduced forelimbs, improving their predatory efficiency. Behavioral adaptations also emerged during this time. Fossilized trackways indicate that many dinosaurs, such as sauropods and hadrosaurs, traveled in herds, providing protection against predators and improving access to food sources. Evidence of nesting sites suggests that some dinosaurs engaged in parental care, ensuring higher survival rates for their offspring. The Jurassic period represents the pinnacle of dinosaur evolution, showcasing their incredible adaptability, diversity, and dominance. This era laid the foundation for the continued success of dinosaurs in the Cretaceous, solidifying their place as the rulers of the Mesozoic era. 7. Competition between dinosaurs and other animal species. Competing species, marine reptiles and mammals. While dinosaurs dominated terrestrial ecosystems during the Triassic and subsequent periods, they were not alone in the evolutionary race. Other animal groups, including marine reptiles and small mammals, played significant roles in maintaining ecological balance and contributing to biodiversity. Marine reptiles, such as ichthyosaurs and nothosaurs, were the rulers of the oceans. With streamlined bodies and powerful tails, these creatures occupied top predatory niches, preying on fish, cephalopods, and other marine animals. Although they were not dinosaurs, their success in aquatic environments demonstrated the diverse evolutionary paths reptiles took during the Mesozoic era. Small mammals also emerged during the Triassic, evolving from their synapsid ancestors. Though overshadowed by larger reptiles, these early mammals adapted to nocturnal lifestyles, allowing them to exploit niches that dinosaurs and other diurnal predators could not. Feeding on insects, seeds, and small vertebrates, mammals contributed to the balance of ecosystems by controlling insect populations and aiding in seed dispersal. Their adaptability and resilience ensured their survival through mass extinction events, ultimately setting the stage for their later dominance. Ecological relationships and nutrition. Dinosaurs did not exist in isolation but were part of intricate food webs that drove evolutionary change. Herbivorous dinosaurs like Plateosaurus and Brachiosaurus relied on gymnosperms and other vegetation for sustenance, while predatory theropods such as Heterosaurus preyed on herbivores and smaller reptiles. These interactions created a dynamic system of checks and balances, influencing population dynamics and driving the evolution of both predators and prey. The competition for resources was not limited to direct predation. Marine reptiles competed with fish and other aquatic species for food, while mammals and small reptiles often vied for similar prey in their environments. The competition among these groups led to the development of specialized feeding adaptations, such as sharp teeth for carnivores, grinding jaws for herbivores, and varied locomotion styles to improve hunting or foraging efficiency. These ecological relationships and competitive pressures fostered innovation, adaptation, and diversification, ensuring that ecosystems remained resilient despite environmental upheavals. The interactions between dinosaurs, mammals, marine reptiles, and other species underscore the complexity of Triassic ecosystems and highlight the interconnectedness of life during this transformative era.